Hey guys, we're going to be doing 6.5 examples 4, 3, and 2. As you can see, we have r is equal to 3 sine 4 theta. We have the graph here with 4 petals with petal length of 3. I'm going to sketch that and make some observations. We're not going to do the substitution tests with symmetry. So if we want to sketch this, because we have 8 petals, and now we understand the characteristics better, remember sine of even number of petals or even frequency gets you double the number of petals as the frequency, so it's going to be 8. But because it's sine, it's not going to have petals on the axis. So, it's going to have that and that. Because right now that's going to make sections for 4 petals. So we need to add some more to get space for 8 petals. Each petal is 3 units away from the pole. So right in between each section, 3 units away would be right here, 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 all the way around. Now when you sketch these rough sketches, it doesn't really matter how you draw it in what order, because I can't see, and the most important thing is understanding the symmetry and petal lengths and where the petals are, but the order is not the most important thing when you draw it. But I'm going to do my best to draw it in the correct order. Out to the pole, out away from the pole, back to the pole, 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 and away from the pole, back to the pole. So you guys get the idea. That's how you would sketch it. If you look at the characteristics, the domain is infinity to infinity, because r is equal to 3 sine 4 theta is not bounded by any restrictions in terms of what you can plug in for the angle. The largest radius that can be outputted is 3, and sine can have a -1 value, so then -3 would be the smallest output for radius. So the range is -3 to 3 inclusive. It is continuous, because as you can see, when I drew those petals, I could continuously draw them without lifting my pen. It is symmetric over x, y, and the origin, because again, it's a even frequency rose curve. If it was odd, then because it's sine, then you would say that it's only symmetrical over the y-axis. It is bounded because it's limited to a radius of 3 or -3. It doesn't go beyond those. The maximum radius is 3. There are no asymptotes, meaning there's nothing that it's approaching but never takes on the value. I know we have these asymptotes that I drew to help me sketch it, but those aren't traditional asymptotes. If we go to example 3, that's really easy to figure out. What's the maximum value of this? Cosine can output a maximum value of 1, so it's just 3 times 1. The maximum value here is going to be just 3. Over here, cosine can output a maximum value of 1 again, so it'd just be 2 plus 2 times 1, so the maximum value of this is 4. Understanding this is going to help us kind of lead into Leibniz and cardioid curves coming up. And that's it.